The stream of new participants slowing down. So welcome back, everybody, to the second day of the yearly user meeting. This first block will consist of 2 talks by Rene and by Timo and Quang. And then we'll have, after the question time, we'll have a general discussion about, for example, the future developments that people want to see. So I guess, Rene, if you want to start sharing your screen.
I can do that.
Rene will speak about new features and future directions. So yes, looks good. You can take it away, Rene.
Okay, great. Thanks, Anne, and welcome back, everyone. Today, I want to give a brief overview over what happened with Aspect. And while preparing this, I stumbled upon this slide from a few years ago that we prepared for the Aspect 2 release in 2018. And since then, a lot of things have changed, and I want to summarize some of them. First, we have to start with this title slide. So obviously, the version number has changed. As we also already briefly mentioned yesterday, I think Aspect's name has changed since 2.0. It's now the Advanced Solver for Planetary Evolution, Convection, and Tectonics, to include all of you who don't really work on convection and all of you who don't really work on Earth, but nevertheless use Aspect. Also, the people who have contributed to this have grown enormously over the past years. Thank you, everyone, for that. But there are also things that haven't changed in Aspect, and that is what we want to base this software on, which are modern numerical methods, so adaptive mesh refinement, modern nonlinear and linear solvers, higher order discretizations, selection of advection methods, and that we want to build Aspect on other people's work. So in particular, the DL2, Trilinos, and Pforest libraries provide incredibly important contributions to the models that we do. But that also has the benefit that we have their tested foundation, and we don't have to write all of this ourselves in Aspect. We still try to maintain the usability and extensibility of Aspect. The manual has grown significantly from the 2.0 release. We now have 112 cookbooks and examples in the folder. Surprised when I checked that number recently. The number of tests has doubled since Aspect 2.0. And we have also extended the parallel scalability. But most importantly, also Aspect is still developed as a community code. So we have an open source license, but we also try to develop everything in the open and encourage contributions from everyone and try to create a welcoming community with meetings like this one. A few more statistics. You see this presentation is more about statistics than flashy animations and pictures. I'm sorry about that. I hope it will still be useful to all of you. So you probably already know where we have our website, and that Aspect as a project is maintained by a few people who put in more than just the work that is necessary to do their research. So we have now 8 maintainers who you can ask questions, who try to help out on the forum, who try to develop code that's not necessary for their research, but that's just necessary to maintain the project as a whole. The number of contributors has grown since the 2.0 release. We have now at least 100 people who have contributed code in some capacity to Aspect somewhere. And it's continuing to grow every year at the hackathon and outside of the hackathon. And we are very happy about all of those contributions. And most significantly, I found was that the number of publications that cite Aspect has grown enormously since the 2.0 release over the past years. 6 years ago, we had 30 publications that used Aspect in some form. Now we are up to 192, and I just heard we have even more submissions since yesterday. So this number will continue to grow. Please feel free to check if we are already tracking your publication, and if we don't, then send us a message. So why did we decide to release Aspect with a new major version, 3.0? Well, first of all, it includes a lot of growth over the past 6 years. So over the past 6 years, we had about 9,350 changes in Aspect, little commits, large commits, big features, and 5 new releases. And this is very comparable to the changes that we had between 1.0 and 2.0, which was about the time from 2011 to 2018, 7,200 commits. But also every software kind of accumulates these little bits and pieces that you could have done better if you had just thought about it for a bit longer, or things that you have implemented, but that don't quite work in the way that you expected them to, and you just need to change them. So this big version step allows us to break some of these things to remake them in a better way. And this, in the long term, hopefully allows us to grow Aspect further. Some of this new functionality I will discuss in this presentation. First of all, the new default Stokes solver will probably affect many of you. We have a complex mesh deformation system. I'm not going to talk as much about that. You have already seen examples of surface evolution yesterday. We now have the opportunity to use multiple particle systems, and I'll briefly explain what that means later. We have a new plugin for the Visual Studio Code editor that makes it easier to modify Aspect parameter files. And there are many more significant changes, which you can look up on the releases page of the GitHub repo. Before we get into all of this, I wanted to briefly explain the modular aspect of Aspect again, because this frequently comes up, but we don't explain it very much in the documentation, and also not as often in talks, because it just doesn't fit into one particular topic. So we say Aspect is a modular software, and what we mean by that is that there is kind of a core of the software, which we call simulator, that contains all of the core functionality and that interfaces with those low-level libraries, DL2, Trilinos, Pforest. But then this core of the software interacts with a lot of different systems, which are called plugins. And these plugins are simpler because they only focus on one particular task. To give you an example for what that looks like, we have different systems for the initial conditions, the boundary conditions, the geometry, and the gravity in the model. You are probably familiar with those. They interact with the core simulator, and the core simulator also interacts with the adaptive mesh refinement system and the material model. What I marked in red here on this slide are all of these systems that experienced a major overhaul in this Aspect 3.0 release. As you can see, a lot of that is actually inside of the simulator, so you might not have noticed this as much if you're mostly working on, let's say, your own plugin, your own initial temperature or boundary condition. And that's good. We try to keep it that way. I just wanted to say that under the hood of the simulator, there have been some larger changes, in particular, the interaction between the nonlinear and linear solvers and the assemblers. This whole new system here, the mesh deformation system, that's responsible for deforming the mesh in different ways, including the surface evolution that we saw yesterday. A new system for time stepping that allows, for example, to cut back a time step in case the nonlinear solver doesn't converge in a time step. And a reorganization that is not finished yet, but that is started, of the material model, where we try to separate the elements of an equation of state, a rheology, and a reaction model from each other, and maybe more features in the future, for example, the thermal conductivity. Because frequently every material model is actually composed of a combination of these different elements. And frequently you want to pick one equation of state, but then a different rheology, and then a third different reaction model. And currently you have to write a whole new material model if you want to do that. And long term, we would like to get to a solution of combining these more easily. The other big change that I wanted to briefly discuss is how to interact with Aspect parameter files. So the graphical user interface of Aspect, so to speak, in version 1.0 looked something like this. You took your favorite text editor, you opened the parameter file, and off you go. You can write parameters in that text file. I don't know how many of you were aware of the fact that in version 2.0, we actually introduced a little graphical program that could list the input parameters in a table-like or tree-like structure that allows you to change the values and then in the end save a complete parameter file. This was a really nice little program that always had the problem that it had to use the Qt, graphical user interface libraries, and you had to compile this yourself before you could use this. It was always a bit cumbersome, and I don't think it ever was used very much, even by the developers. For 3.0, we found a nicer solution, or more specifically, our user Gu found a nicer solution and created a plugin for the Visual Studio Code text editor, or IDE, the integrated development environment. If you are using Visual Studio Code anyway, it's as simple as searching for VS Code-Aspect on the Visual Studio Code marketplace or in this extension bar that you get in Visual Studio Code. If you're not using Visual Studio Code yet, I would recommend to try it at some point. If you're not already familiar with one integrated development environment and want to stick to it, it's really useful because you can use it to essentially edit code and parameter files and have your terminal all in the same window, and allows you to quickly switch between the code that you're developing, the model that you're setting up, running the model, and then even starting ParaView in the end and looking at the model results. Anyway, I wanted to bring this up. The screenshot up here shows you how that looks like if you have the extension installed. So if you have an Aspect parameter file open, you can just start typing and you will get an autocomplete option of all of the parameters in this subsection, including possible values and the documentation of the parameter. It's incredibly useful for writing parameter files. One brief mention here is that this plugin is currently at the state of June last year. So the latest changes to the parameter file are not yet known to the plugin. It doesn't matter as much unless you're writing inside that subsection that changed. It works well for most of the parameter file, and we're working on releasing a new version for Aspect 3.0. Another topic that I wanted to briefly mention is the compatibility to older input files. We usually try to keep Aspect parameter files as compatible as possible going forward. So we try not to break parameter files too often. For this version jump, we decided to make some changes. For example, a lot of the particle parameters have moved to a new subsection. They previously were in the post-process subsection, but particles have developed into their own system. They are not really a post-processor anymore. So we have decided to take the cut now and move a lot of the particle parameters into their own subsection, except for the ones that actually deal with post-processing, like how often to write the output files. We know this is annoying if you try to run old parameter files with new models. We try to make the change as easy as possible by providing update scripts. Sorry. If you check the directory contrib utilities, there's a file called update prmfiles.sh. And if you execute that script on an existing parameter file, most of the parameters will be updated to the new version. We couldn't make it work for every change that we did, but many parameter files just work after running that script. In some edge cases, you might have to manually change a few things, but the bulk of the changes should be updated by that update script. Okay, I wanted to mention two things that changed about the modeling itself and what you might want to keep in mind about them. The new default Stokes solver and how to run this multiple particle systems. So the default Stokes solver has changed in aspect, but the new solver is not new. It was published in 2021, and it was an option in aspect for quite a while. Konrad, Timo's former PhD student, and Timo implemented this solver over the years. It's a geometric multigrid solver with a matrix-free assembly. Don't worry too much about the details. We're going to hear a bit more about Stokes solvers in the next talk, although not as much the matrix-free assembly. Here, if you're interested in the details, I invite you to read the paper. But the bottom line for us is that in the optimal case, it can be up to 3 times faster and use up to 10 times less memory than the old Stokes solver. That's in the ideal case. Not every time it will give you that advantage, but often it will be significantly faster and use less memory. There are 2 important things to keep in mind. The material averaging with the new solver works slightly differently. So if you're not aware, you can set aspect to average the material properties across a cell, which generally improves the solver behavior if you have large, say, viscosity contrasts, for example, across a cell. The default behavior for the old solver was to not use this material averaging. The default behavior for the new solver is that it uses a material averaging that only averages viscosity. And most of the time, it will use the option project to Q1 only viscosity, which means it will project the viscosity into a linear function in every cell. If you're using the Newton solver, it will, for technical reasons, choose a different averaging scheme, the harmonic average, only for the viscosity. So if you are comparing results with the new GMG solver and the old AMG solver, and you do not select a fixed material averaging, you might see slightly different results, which is most likely because of this material averaging, not because the solvers actually give you different results. It can also happen that if you manually disable material averaging, the new solver will not work for you. You should then get an error message that tells you that you will have to enable material averaging, at least for the viscosity for the new solver. The second note to keep in mind is that this new solver depends a lot on native CPU optimizations, so using the vector units in modern CPUs. This is important to mention because if you do not enable these CPU optimizations during compiling aspect, the performance of the new solver can actually be worse than the performance of the old solver. You can check if these optimizations are enabled in the output of every aspect model. In the header lines, it will tell you the vectorization level that was used to compile aspect. And if you check this when you run aspect in release mode, you should either see level 2 or level 3, depending on the CPU that you're using. If you see level 1 or even level 0, that means you haven't enabled these optimizations when compiling aspect, or you're running a CPU that is not supported, or not, the performance optimizations are not supported. If you don't see this, then check the installation instructions in the manual for how to enable this while compiling aspect. And DL2, I think. So you might have to recompile DL2 as well. And the final note on the solver, you can still select the old solver in the parameter file with using this input parameter. So if you don't want to use the new solver, you can always go back to the old one. The next item that I wanted to discuss was how to use these multiple particle systems. So as I already mentioned, most of the parameters about particles moved into a different subsection. But you can also now have more than one particle system. So there's a new parameter in the subsection particles that's called number of particle systems. And you can set that to a different number. And so I think by default it's 0. You can set it to 1, 2. Each particle system will then get its own subsection, particles, particles 2, and so on. And for each subsection, you can set different numbers of particles, different properties on the particles, and so on. The only limitation about that is that each particle property can only appear in one of these different systems. So you can, for example, track the fabric of the material on one set of particles, but the composition of the material on another set of particles, which is nice because for some properties you need many particles, for other properties you want fewer particles. By default, you can create up to 2 particle systems. If you want more, then you need to change a variable during compiling aspect. The variable is called aspect maxnum particle systems in CMake. This has technical reasons that we would like to avoid, but couldn't figure out how to avoid. So if you need more than 2, you have to change something while compiling aspect. Okay, one slide about future developments in the material model. So we have already talked a bit about what kind of new features might be coming in the material model yesterday, at least in the discussion, I think. Currently, there are several efforts on the way to improve Aspect's material model system. And I see I'm running over time a lot, so I should speed up. We can discuss this during the general discussion later. And that's it. I thank you for your attention. And I hope that in 10 years, I can post another slide with another picture of the Hackathon 2034. Thank you very much.
Thank you, Rene. That was a very useful summary. As yesterday, the question time will be at the end of the 2 talks. So I think Timo and Quang can share their screen, and then we'll make sure to have enough time for questions after their talk.
Can everyone see my screen?
Yes, not in presenter mode yet, but yes, perfect.
Hey everyone. Today I'm going to be talking about a new Stokes preconditioner for models with large viscosity contrasts. The preconditioner itself is not new. It was introduced by Rene et al. In 2017, but the implementation in Aspect is a work in progress. That's the new part. I will mention what a preconditioner is after I set up the benchmark problem, but for now, when I say the word, just think of it as a transformation to make your solver work nicer. So whenever you run a simulation in Aspect, you're going to be doing what's called a Stokes solve. And you're solving the system of equations outlined here for velocity u and pressure p. This gives rise to the discretized form mx equals b, where m is equal to a, b transpose, b, and 0, where a is your viscous stress matrix, b transpose is your gradient, and b is your divergence. These solves will take up a majority of your computational time, and as such, we want to make sure that they're robust with respect to mesh size. So if you keep refining, you don't want the number of iterations to blow up, and with respect to viscosity contrast. And we'll see that it's not always the case that the robustness holds. So in order to compare preconditioners, we're going to need a benchmark problem, and we use the NSyncer benchmark in Rene et al., which is also an Aspect. It's Aspect benchmarks NSyncer. And in the PRM file, you can adjust a lot of things, but this number of syncers and the dynamic viscosity ratio. And what the dynamic viscosity ratio is the quotient of the maximum viscosity and the minimum viscosity. Thank you, Arushi, for this image. You can see the 8 syncers and the velocity streamlines. So let's discuss preconditioning. Recall the linear system we had before, mx equals b. Our iterative solver might not converge independent of the problem parameters if we just try to solve mx equals b directly with it. Instead, we have to introduce a right preconditioner p inverse and multiply m to the right by p inverse. So you end up with m p inverse px is equal to b. Then you can solve m p inverse y equals b. This is the preconditioned system, and the iterative solver should behave nicely. And you recover your original solution x by applying p inverse to y. So notice that we're going to have to be able to compute the action of the preconditioner in order to recover our solution x. We haven't introduced the form of p inverse yet, and it's going to be chosen to be of this block triangular form. So you have your matrix M, your preconditioner p inverse, which is chosen to be of this form A, B transpose 0, negative S inverse. And we see that when we multiply M and P inverse, we get this block lower triangular matrix with the identity block on the top left and this highlighted portion B A inverse B transpose times S inverse in the bottom right block. And for some context, our solver converges quickly if the eigenvalues of our system are clustered around, say, 1. So for MP inverse, the top left block has eigenvalues 1, since it's an identity matrix. The bottom right block, however, we need to control. And we do that by choosing S inverse to approximate B A inverse B transpose inverse. The reason we call this S inverse is because B A inverse B transpose is known as the Schur complement, and S inverse will act as the Schur complement inverse. So in aspect, there's a standard approximation for the Schur complement, and that's given by the pressure mass matrix weighted by viscosity. So you can see this approximation for the Schur complement inverse, and this might not be robust with respect to high viscosity contrast or mesh size. So what Rudy et al. Propose instead is this weighted BFBT approximation for the Schur complement inverse. It is the long expression with the 2 highlighted portions. So I'm not going to go through the derivation, but the weighted BFBT method consists of 2 pressure Laplace solves, and these are the highlighted portions. The middle block is just a sequence of matrix multiplications. I should note that C and D can be any symmetric positive definite diagonal matrices, but weighted BFBT chooses C and D to be the lumped velocity mass matrix weighted by the square root of viscosity. And what lumping is for each row of your mass matrix, sum up every entry and then put it on the corresponding diagonal. So this forces C and D to be diagonal, which is good because we're going to be computing C inverse and D inverse. And for diagonal matrices, this is just the reciprocal of the diagonal entries. So next, I'll show results for the n-sinker problem. Recall that the dr eta is the dynamic viscosity ratio. So as that increases, the viscosity in contrast are increasing. And then the problem's harder, the more sinkers you introduce. We see that for 4 sinkers, weighted BFBT doesn't quite perform that well compared to weighted mass. But as we add more sinkers, we see that weighted BFBT is fairly competitive. Notice, especially for the highlighted portion, weighted mass matrix requires 260 iterations, whereas weighted BFBT requires only 89. But we have to keep in mind that one iteration with the weighted mass matrix approximation is not the same as one iteration of the weighted BFBT approximation. And this is because for the weighted mass matrix approximation, you're just doing one mass matrix solve. Whereas for weighted BFBT, you're doing 2 pressure Laplace solves. However, the pressure Laplace solves are on the pressure space, so that's a bit, the pressure space is a bit smaller, so those computations might not be as expensive. I'm finding that one iteration of weighted BFBT requires about 30% more time than one iteration of the weighted mass matrix solve, and this is just a very rough estimate that I did using NSyncer with 800,000 degrees of freedom. Next, we look at a table for the spherical NSyncer problem, and we can see that the numbers are comparable. Maybe weighted BFBT is not very competitive here, and that might be for a few reasons. Notice that I'm only running this with 200,000 degrees of freedom, and weighted BFBT performs quite poorly for coarse meshes. One possible adjustment you could make is there's a table of weights you use for coarse meshes, but it's not implemented into Aspect yet. Also worth noting, this isn't the default transition zone viscosity jump value. I think in Aspect benchmarks, it's like 10. And here's a picture of the spherical NSyncer problem that I took from a paper. Now, this is a table of various benchmarks I ran the weighted BFBT and weighted mass matrix approximation on, and notice that we don't have convergence for multi-component Steinberger and grain size ridge. We believe this might be due to boundary conditions. Weighted BFBT performs well for simple boundary conditions like Dirichlet. But there are adjustments that can be made to the weighing matrices to improve it for weighted BFBT, and that's a work in progress. If you want to try out weighted BFBT for yourself, set the Stokes solver type to be block AMG. Make sure to set use weighted BFBT for sure complement to be true. Use locally conservative discretization to be false, and then use full A as the full A block as preconditioner. I attached a sample PRM file for the NSyncer problem in case anyone wants to play around with it. But also keep in mind that the latest changes I've made aren't pushed into Aspect yet, so you might not get exactly the same results, but it should work for NSyncer, I think. For future work, I want to implement BFBT with matrix free, and then there are a lot of boundary adjustments to be made. So for Dirichlet boundaries, higher level of refinements, there are different weights you can use to dampen the boundary effects. And then for non-Dirichlet conditions, we need to find a way to ensure convergence independent of parameters. That's all I have.
All right, thank you, Quang. Then we now have 15 minutes of questions to both speakers. So please raise your hand if you have a question. You can raise your actual hand or use the react button. Rene, be my guest.
I have a question, Quang. I have a question. Very cool that that BFBT is now working for several cases. Two questions actually. One is when you said that one BFBT iteration is 30% more expensive than one weighted iteration, did you mean just the inner solve for the bottom right block, or did you mean the overall Stokes iteration, the outer iteration?
So what I was comparing was the two pressure Laplace solves for weighted BFBT and the one mass matrix solve for the weighted mass.
So just the inner part. Oh, that's nice. I mean, that's probably not too bad if you compare that for the, like, there are other costs of the Stokes solver as well, right? So that shouldn't be too bad in the global sense.
I thought it was the cost of one Stokes iteration that was 30% more. The whole thing, including the velocities.
Oh, yes, you're right. I divided the time by the number of Stokes iterations.
So basically,
okay.
It's an estimate, but basically that would mean if you see the 90 versus 260, you need to add 30% to the 90, and you're still ahead of the 260.
Yeah, which is still less than 260.
But this is just trying it out, first try on a laptop, whatever. So I don't know how this scales to larger problems. I have no idea how this is for more difficult simulations, because it depends on the ratio of how much time you spend in the A block versus the show complement. And so it's just a rough estimate. So it's not a factor of 2. It's not exactly the same, but it's somewhere in between.
Yeah. But at least it's in the same order of magnitude. And I guess the second question I had was in that table that showed the number of iterations for the NSYNCer benchmark, even the weighted BFBT showed somewhat of an increase with increasing viscosity contrast and number of sinkers. Is that expected? Is that also what Rudy had in their paper? I don't remember the details. In my head, I kind of had this rosy picture of no increase in iterations at all with viscosity contrast and blobs, but maybe I was expecting too much.
I'm not quite sure. Yeah, I think that one problem is just I don't quite know if the pressure scaling is correct yet. I'm positive that what I have is working better for most problems than what's in aspect right now. But I need to do a bit more work on like keeping track of the pressure scaling, I think.
Yeah. I didn't mean to criticize the stuff. I mean, it's super exciting to get a solver that is less dependent on the viscosity contrast in the model. I was just trying to get a sense for what kind of improvement we can expect at the end, like seeing theoretically.
It's a good question. I also don't know the answer exactly. I think their numbers are better. That could be due to their boundary corrections that we're not doing yet. It could be that their velocity solver is more robust, because if you increase the viscosity ratio, the AMG for the velocity block might also degrade. And so not quite sure. So it could be better, or could be better than what we're currently seeing in the future.
So
Even
we
better.
will be waiting for exciting news.
Yes.
In the paper, the boundary corrections do seem to make a pretty big impact when it comes to making sure that iteration numbers stay constant.
Thanks.
All right, next up is Daniel.
Hey, yeah, super interesting. First, just a comment about the question Rene just asked. If you're interested in like trying this on a geophysical setup, I'm happy to try the BFBT preconditioner on my 2D subduction models. That might be a little gateway, or I can send you those files and you can test them yourselves if you want like a realistic high viscosity contrast problem. But then my question is actually for Rene and the particles. These different particle systems, is it already like functionally possible to advect the different particles with different velocities for when you have two different phases, or is that not implemented yet?
I'm actually not sure. I would have to check. I know that by default, all particle systems will be advected with the same velocities. But we do have one particle property, I think it's called melt particle or something, that if the particle is in a region with melt, it will be advected with the fluid velocity instead of the solid velocity. But I think that was implemented for the two-phase flow solver at some point. So I don't know if, for example, that would work with your Darcy velocity in the models. But you can see how that is done and then maybe adjust it to whatever application you have. So by default, no, but it shouldn't be too hard to implement that in the code.
Okay, super cool. Thanks.
Sean?
Thanks, Rene and Quang, for those presentations. I had a question for Quang and Timo. Again, this is a theoretical question. I don't know if it's possible to answer this, but so then there's some problems where we impose the structure like faults or subduction zone, and we start off in the model with extremely high viscosity contrast. So we give aspect a very hard problem to solve. And there's and for some problems we can't, we can only solve it up to a relatively coarse linear solver tolerance. Let's say 1e - 4, 1e - 5, and beyond that, it breaks, and we can't get the Stokes solver to converge. I was curious if the BFDT method, in addition to both improving like speeding things up, would it also potentially help with solving in problems which the current methodology can't do? I mean, so basically, could you solve a more complicated problem with higher viscosity contrast?
That's difficult to answer depending on the boundary conditions. So for example, Steinberger, I can't get to converge. I don't know if I put that in the table, but I think that had periodic boundary conditions. And then I also had multi-component Steinberger not converging, and that has tangential boundary conditions. So it might be that if we implement the Dirichlet boundary corrections, we could solve more complex problems even with non-Dirichlet boundary conditions. Maybe those weights work, but it's not clear to me if that would be enough to resolve it. Does that answer your question?
It does, yeah. And just echo Daniel, if you ever need test problems, just let us know. We have a whole library of complicated problems. So just please let us know how we can help. Thank you guys for continuing on this work.
That's very cool. Thank you.
Yeah, John, your problem you sent the other day, we're already struggling with, but some of these things we can work out. Let me try to answer your question in a bit different way. The harder the problem becomes, the more iterations the current Stokes solver needs. And if you wait long enough, the new solver will not make unsolvable problems solvable. but it depends on your definition. Maybe the current one needs 10,000 iterations and you don't wait that long, whereas the new one may be able to do it in 200. So practically speaking, there will be some problems that will be tractable that were not tractable before. And so in the paper, for example, they have examples where they make the viscosity ratio like 10 to the 10. And then the mass matrix approach doesn't work, basically. But the new one does.
Thank you.
Sarah, you're next.
Question is for Rene. It's about one of the last slides you showed on planned material model features. And you may or may not be able to answer it because it's listed with Bob Myhill. And I was just wondering if you knew what kind of changes were to expect about these composite really logical models. Because I know there's already one in there. Yeah.
Yes. So I think Bob is working on a rheology that combines all of the different flow laws in a slightly more consistent way than the viscoplastic model does at the moment, and in particular also in a way that makes the viscosity differentiable with the strain rate and the other material, the other input parameters. So, for example, in plasticity, we currently always have the problem that either you're plastically yielding or you're not. And at that transition between the two regions, you always have a break in the derivative of the viscosity, which is always hard on the solver. And in his implementation, he does that differently by, I forgot, harmonically averaging, or like the transitions is smoothened out, which will hopefully help the solver to converge in these complicated rheology cases. So it's not, as far as I understand, it's not a completely new rheology, but it's taking the pieces that we have and combining them in a different way that is still accurate, but hopefully better for the solver.
Okay, thank you.
Juliana?
Oh yeah, I also have a question for Quang and Timo. And so basically it goes in the same direction of what John and Daniel said. So what kind of problem would you want to test it on? Just because what I remember at the hackathon, I gave you these Steinberger and grain size ridge models as examples, but it seems they were not working the way we were hoping. So I was just wondering if you have an idea of what other problem, like what properties the problem instead needs so that it would work well for testing.
I think the lack of test problems is not the bottleneck right now.
Okay.
Because we need to implement the boundary corrections to make the iteration numbers a bit lower. We need to handle different kinds of boundary conditions, and we have the test problems like Steinberger, continental extension, etc. Some of them are not working, and so we know what we have to do and what we have to play with. As soon as those work, we're going to make a pull request and put the current state into aspect. And then we can start looking at larger models, more complicated models. And then it's very helpful to have difficult problems to try.
One thing
That
I
makes
did want to
sense.
say, though, is with Steinberger not working in multi-component Steinberger as well as grain size ridge, when I change the boundary conditions for velocity to 0, they do converge. I know that physically doesn't make sense, but maybe it's worth noting.
Okay, there were just 2 raised hands and now there are 3, but maybe we can stick to the 2 so that we don't get too much over the scheduled time. So Shangxin, you're next.
Okay, so sorry I missed the first day of meeting. I have a quick question for Quang and Timo. And when from your slides, I noticed that you are mainly focused on the testing the convergence efficiency of your new preconditioner. However, I think another important aspect of the solver is to how the solver changes the accuracy of the solutions. So I wonder, do you have some plans to also compare the accuracy of solutions between yours new solver and the previous default one? Yes. I know because I know that the solution for the strong lateral viscosity variation is challenging because there are no analytical solution for this. However, do you have your own plan to compare the accuracy of solution between your method and the default one? Yes.
You want to answer, Quang?
I think the computed solutions would be the same, and this is verifiable by just opening the images in pair view. Your preconditioner, you recover the original solution from it. So you do a transformation on your original system, but you do have to transform back to recover the original system solution. So I don't think your solution would change with the preconditioner. It shouldn't for any preconditioner.
Yep.
Okay. All right.
Great. Kyunyi?
Yeah. I also have a question to Quang and Timo, kind of following what Juliana and John have going over. So I'm just curious because I noticed that for the multi-component Steinberger model, my solver always fell without like any big viscosity contrast, and you mentioned it's because of the tangential boundary condition that is set up in the model. And I'm just wondering, would you have, like, given the fact that I'm still need to run my model in a box rather than be able to run it in a full analyst, what kind of boundary condition setting may help the model to converge? Because right now I almost seeing like with just like less than 10, like less than 100 times of viscosity variations, my models the solver, the preconditioner can still fail me, even after thousands of iterations.
Timo, do you have any idea? I'm not familiar with the problem enough to say what boundary conditions would work.
I also don't know what the precise reason is for it failing or not working well. One thing you can try is if you do zero velocity on the boundaries. I know that's the least favorite thing to pick, but it's the easiest for the solvers. And so if that fixes things, then the second thing would be to have something that less drastical would be to have something that removes the null space. So if you have like an annulus and you have free slip on both, then you have the free rotation, right? So that's a challenge for the linear solver as well. You can remove this by playing with the null space settings or by prescribing something like zero on the one of them inside or outside. If that makes a big difference, then that is the reason. If it doesn't make a big difference, then there's something else with this problem. The problem with the Steinberger we looked at is that it's in a quarter annulus with periodicity, and that's another challenge, different challenge.
Thank you.
All right, thank you to the speakers and to everybody asking questions. We now have a scheduled general discussion, and in the program, there were already a few questions that I just listed here in the slide. I hope you can see that. Just to get the discussion started, but if you want to ask a different question, please feel free to do so. Rene.
Yes, maybe we can get the one very precise and concrete question of this list right away, and then we can focus on the more open-ended ones. Yes, exactly that one. So every 2 weeks we have like a mini version of this user meeting, just 1 hour with everyone who wants to discuss something, joining and just talking about what's going on at the moment, and if there's currently a problem with the model or found a bug and want to discuss this. And we usually do this every second Monday from 5 to 6 p.m. European time. That's 8 to 9 a.m. Pacific time, and 11 to 12, 11 to noon East Coast time. We have kept this time and day for a while now, mostly because we kind of adjusted to it. And it's one of the few times where that's possible for everyone in the US and for everyone in Europe. Of course, it's unfortunate that this then also means that it's very hard to join for everyone from Asia. So we wanted to bring up the question if this time is generally a good time, or if we, in general, should look for a different day or a different time to have that meeting. I know that's a hard question to ask in such a large group. We would have to make some sort of poll, but I think for most maintainers have adjusted to this time more or less. But if there are compelling reasons to move it to a different day or a different time, then we could do that. Any opinions on this topic? Oh, and if you want to participate, this is usually announced in the forum. So there's a pinned post in the forum at the top that says regular user meeting. If there are no opinions, then we probably just keep the day and time. But this is your chance to speak up if it doesn't, if it's not a good idea to have it then. Okay, seems like that's settled. If you still have thoughts on it, feel free to open a forum post and ask us.
So the final point was added to the program, I think, yesterday. So I'm kind of curious how that question came up.
Yes, that was brought up in the discussion session yesterday. I forgot who brought it up. Are you here right now? Maybe not, but we had a question anyway for the future, or let's say currently we saw a lot of models yesterday that showed the coupling between aspect and fastscape, and we had someone asking if there are plans to expand this in the future to other geometry. Like currently it's limited to just box geometries, if this is expected to be extended, and we had a little discussion about it. And I just thought it's interesting for everyone to hear. Maybe there are ongoing efforts to, first of all, couple aspect to a newer version of fastscape that would also support spherical geometries. Then that there's an ongoing effort to couple aspect with LandLab in the US. There's a project by Timo and Wolfgang and some others.
Yeah, maybe I can say something about this. So it's Timo and John and me, and then folks from outside the aspect community. What we want to do is couple aspect with LandLab. LandLab is a system. I would say that it works differently than aspect, but the idea of LandLab is that it allows you to write simulators for surface deformation processes. So this is erosion models, but then you can also have, transport of material in the ocean. You can have vegetation models that are coupled to this. And so the idea is that we can couple aspect with these LandLab models that describe how the surface deforms above the ocean, below the surface, below the ocean, for example. But this is this is going to be a multi-year effort. LandLab is not currently run in parallel, for example, so there's a lot of infrastructure work that we have to do. At the same time, LandLab is really cool because it has hundreds of models that can describe how the surface evolves. And so that's what we wanted to do. I don't know LandLab and Fastcape well enough to compare the two of them, but my understanding is that LandLab is far more versatile with regard to the models that you can run on the surface.
Great, thank you.
A thought on that, would it make sense to extend Fastcape with the, what's called LandLab? With the options it has, or is it a different setup? Like,
Perhaps, I don't know. I think one of the challenges is that Fastcape is largely a European project and a European funded project, and LandLab is a project that is largely funded by the United States. And so I think the two of them have been working a little bit in parallel. I mean, yes, of course, it would be, if we already have Fastcape interfaces, then it would be nice if Fastcape could learn all of the things that LandLab already does. But I think the underlying approaches of these two projects are just very different. So LandLab is written in Python. And one of the things that I think I learned about that community is that the surface deformation community is not computationally savvy like the community that uses Aspect. Right? So there's a lot of folks who are ecosystem modelers who, know everything about exactly how mangroves, grow at the shore, for example, right? So these are people who have very different backgrounds than what the subsurface geophysics, geodynamics community has. And so I think it's going to be difficult to bridge this. I think that Fastcape really comes out of the geodynamics community, and LandLab comes out of, the geology, surface processes, ecosystem community. It's just different communities, and I am not sure if it's easy to take material from one into the other community.
I can just add that Fastcape is being rewritten at the moment. So it's not just expanding to a new geometry, but it's actually like being rewritten in a different language and in a more modular structure and in a parallel way. And of course, it's also continually added to by other researchers that just need different functionality, just like Aspect. Yeah, I just wanted to add that. So the coupling with this new version of Fastcape also is a bit different from the current version we have. John, you have your hand raised.
I was just going to add on to what you and Wolfgang said. I think the idea with the Aspect LandLab coupling, it's not meant to be restrictive or is the only solution. Ideally, there are multiple different codes or libraries that Aspect can couple to for surface deformation. I mean, that's the goal. I mean, as long as people are maintaining these things, then the more options, the better. I mean, I can imagine where there are scenarios where it may be ideal to use the new version of Fastcape for some problems, and then there are some problems where maybe you may want to use the version of LandLab. So then again, I guess just the point is the LandLab effort is not meant to have that be the one solution. It's just another solution, and they'll probably, depending on what your problem you're working on, you're going to want to probably choose different things. Oh, I also want to know there's the Fastscape algorithm, or there's actually a component for that in LandLab as well too.
There.
I wanted to comment on your question in the second bullet point, and really just praise the Aspect community for continuing to value people who contribute in all different ways, like whether you're a user or a developer, someone who just publishes with the code. I think the community does a really good job of being friendly and open to all people who leverage the software. Just want to, give a thumbs up to everyone for that. It's pretty great.
Thank you. Highly appreciate it.
Yeah, that's wonderful to hear. Maybe people have ideas on how this could be done even better, or what is still missing in this community. Rene.
I wanted to bring up one thing, or emphasize one thing that Sarah just said, that there are many different ways to contribute to Aspect, and you don't necessarily have to have a great knowledge about coding to help keep this community open, right? In the forum, there are often questions by people who are new to Aspect and who don't exactly know how to do something. And oftentimes, I'm sure there are people in the community who know how to do this and maybe are just a bit intimidated to reply to these questions and help each other. But these are perfect opportunities for you to help someone else, to give back something to the community, and also just to get to know new people whom you might collaborate with in the future, or who might have a job for you in the future, or who you might want to hire in the future, or whichever connection can be made. So we really value every contribution, especially in the forum, or if you see a typo in the documentation and you know how to make a pull request, but you don't really know how to fix the inner core of Aspect, then feel free to just make a pull request for that typo. Every bit helps to take a bit of load off the maintainers and also to just make Aspect better.
And what you're going to find is that if you fix a typo, you will encounter, friendly people handling your pull request, and maybe next time you add a paragraph to the documentation, and next time after that, you know how to add a little bit of code. I think, none of us have started by adding 1,000-line blocks of code. We all started small, right? I remember my very first open source contributions in 1994, and they were, maybe 5 lines of code, right? And I was fortunate that I had somebody whose name I still remember, Barry Warshaw, who walked me through the process of contributing to open source code in 1994 to Emacs back then.
Perhaps from my view, I don't know if that's interesting, but I just started and I worked with other codes before, and I agree with you that the community is there and that there's a lot of support. But I got the impression when you compare from yesterday to today that you lost or that we lost the all Surface people. So there seems to be still like some barrier where, like people who are more interested in the Surface processes, they use in my opinion, they lose Aspect as the underlying, but yeah, I don't know. It seems like a discrepancy of how deep they dive into it, or perhaps it's just a choice, but it might be also a barrier.
Can you explain what you mean by lost? I think we have 7 less participants than yesterday, but that's completely normal and not different from any other annual user meeting I've seen.
No, but so yesterday I heard a few people saying, "Oh, we do surface process modeling, and then we use Aspect on that." But they do not go, or what I got the impression is that there's no deeper that you test out different like solver schemes, different setups. The way it should be that you should like couple these codes. It's just like you have an underlying standard setup, and then you just use that from the Aspect side. But I might be
Yeah.
wrong.
No, I mean, I don't necessarily think you're wrong, but I think this brings up an interesting question in general, which is how much should you trust Aspect to just do its job when you use it versus benchmarking everything yourself again for your own model, right? Because we try to make sure that Aspect is high quality software, whatever that means in the context of scientific software, and that it's mostly free of bugs, and then that we have benchmarked many different cases. But what does that really mean? We cannot test exactly the setup that you are running. And also even the license of Aspect states that it comes with no warranty that it's working for your case whatsoever, right? Because we cannot assume any responsibility that there's no bug in the software. So it's a good discussion point for how much testing and benchmarking is expected of any user if you're starting to use any geodynamic modeling package, really. And I guess a good guideline would be that you should probably run at least one of the benchmarks that's closest to your application to see how it behaves. But it's unrealistic to expect you to run all of the 100 or so benchmarks in Aspect, understand every one and what their limitations mean for you.
Yeah, yeah. I might be, yeah, good point.
I also think it matters whether you're starting from scratch with setting up a simulation or whether you already have like collaborators who have run similar kind of simulations and setups for a long time and have experience with this setup and how it should behave, right? And then you can take that as a starting point, and you don't need to do as much testing as you would do with a completely new problem.
Yeah. So, like for me, I had the starting point, and then what was kind of unintuitive for me was the way the parameters are written. So the way this PRM files that you like have different levels, sections, subsections, and like the structure. But that might be just my background is different from all codes I've been working with.
Yeah, I guess there always will be a difference between different codes. I see the chat is busy. Let's see what's going on here.
Jon, do you want to announce what you wrote in the chat for everyone to hear?
Okay. So in previous years at EGU, we had a meeting for everyone all the Aspect users who were coming to EGU in Vienna. Is it a good? I asked in the chat, but it's a good idea to meet up again. It looks like several people think it's a good idea. So in that case, I will probably request what is called a splinter meeting, which is just a small room of up to something like 20 people in the room, 20 or 30 people in a room. And then for like an hour and a half, I think these blocks are to just discuss whatever we want to discuss about Aspect. And somebody, I think Cedric just suggested maybe a dinner too, so we can probably see if we can organize something like that as well for anyone who is planning to come to EGU. Thanks.
I'm in. Thanks for suggesting that. Adam.
Hello. I had a question about I guess the fifth point there, and I just think it's a great idea to have like a library or repository for post-processing scripts. And so I was wondering kind of how, is this far along? And if so, kind of how things will be organized? Because I imagine it's pretty tricky when everyone has their own, I guess, do they all have to be attached to a cookbook model, maybe? Or will you organize by kind of domain type or subduction versus mental convection, or is this all kind of in discussion and in the works? I just wondered kind of what the status is on that and how you envisage it, because I just think it'd be really, really useful. And we could definitely contribute some kind of subduction-y things. And also kind of how detailed? Is it kind of just like basic things like plotting a viscosity field with vectors? Or are you thinking about kind of more like the next level, which might be tracking a plate boundary or pulling temperature from the top of a slab? I'm a bit biased, that's my favorite one, but are you thinking that type of thing, or kind of just making the kind of standard plots? Lots of questions there, I guess, but just overall to get a bit of an idea of what you guys are thinking for this one.
John, I think you want to take this one, or?
Yeah, happy to. Yeah. So I mean, Adam, I think it would, like, to answer one part of your question, it would be all levels from the simplest all the way up to the most complex. Like the in the proposal, which didn't get funded, but we're hoping to resubmit probably in like the end of this year or something like this, is the idea is that a lot of these tools people develop, you know, it doesn't matter if you're looking at like an extensional system or seduction system or a completely other class problem. In the end, a lot of this, like the core functionality you develop, it can be applied to a lot of different problems, and there's a lot of redundancy that can be reused. So the hope, basically what we had in this proposal, was that we take an initial series of codes that the people in the proposal had written, and we'd organize this into a more general library, and like organize it into a way where it's like it's not domain specific, but it's functionality specific. And you're right, it's actually real, like the organizational part is really hard. It's hard to think about how you organize all these very diverse tools. We had some idea, but a large part of the proposed work would actually have just been working through the process of figuring out how you actually organize this in a logical way, within the goal being to make it easy for people to add on to it. That's really the key part. It's like the organization isn't terrible. Like the hard part is actually designing the repository in a way where it's easy, it's very modular, and it's easy for people to add on discrete new pieces. But I will send at some point I'll send a follow-up email to the Aspect user list, or like to the forum, asking sort of giving an overview of the idea and then soliciting feedback. We're probably going to do a community poll. I think the reception from NSF, it was generally actually pretty positive, but surprisingly, one of the things they noted is we haven't demonstrated that like there was a clear demand. So which will probably try to have a community survey or poll or something like that. But anyone who's interested in contributing to this or has ideas, all input is welcome here. I will add, in the short term though, is that what can be done if there's like a specific benchmark or cookbook and Aspect, and you've written some Python tools to post-process that, then it would be great if, like, you know, there's a Python contribution folder in Aspect. But also what people can do is put a Python script inside the cookbook folder, which shows how to analyze that. I mean, all of those contributions would be fantastic. Sorry, that was a very long-winded answer.
No, super helpful. Thanks, John.
All right. Cool. There's one more thing in the chat. About the EGU splinter meeting. Yeah. Yeah, exactly. It wouldn't be a separate meeting. Yeah.
Yeah, just as a reply, I don't think this would be intended as like a big new Aspect meeting. It's more a very nice opportunity to get everyone into the same room who's going to EGU anyway.
Yes, and it would just be during the normal meeting, just an hour and a half during, just like, and you can still request a room for that. So yeah, you're right. It's not a separate meeting or anything.
Yeah. Good. So if there are no more discussion points, I think it was also mentioned yesterday that there were some people that wanted to advertise job positions or themselves for a job. So maybe we use this time, I stopped sharing, and maybe we use these last 9 minutes to spend some time on that. I don't know who wants to share a position or a candidate. Menno, Juliane. I also have one. So, okay, Menno, you can start.
So I just started as a associate professor here in Graz, and with the position will come a PhD position for 4 years, and well, that will be on a topic related to aspect and property subduction modeling and the world builder, and basically I'm free to choose whatever subject which is interesting. So if you're interested in just general modeling with aspects, probably I will have the position ready by EGU. So come and talk to me, and I'll be happy to talk. And yeah.
All right, Diana.
Yeah, so I don't have a position myself, but I suggested this because yesterday I got an email from Scott King who said he actually has a position for someone to model mercury, and I think it was about sort of melting and convection, thermochemical convection on the evolution and volcanism on Mercury, and I'll just put the link in the chat, and so then whoever is interested can sort of go and figure it out, and it's sort of it's a postdoc position.
Thanks, John.
I was going to make the same point Juliana had, and that for everyone, please carefully watch the forums, because there's a lot of job advertisements that go out through there. And I was going to, for any of the other students who are looking for long-term positions or postdocs, I was going to recommend I'll put these in the chat, SC40 mailing list and the SCEC, which is the Statewide California Earthquake Center. Both of those mailing lists, almost every week there are job advertisements going on. So if you're looking for positions, those are fantastic places to keep checking if you're not already checking this.
All right. I also want to share a position, and two actually. They're not mine, but I'm a collaborating. Wrong one. Collaborating the project. So this is an ERC starting grant project that Agi Kirali received. And she has in that project a PhD and a postdoc position. The PhD opportunity is already advertised. So this is at the University of Oslo, and it's on anisotropy in ice sheets and in the mantle of the sphere. So, and how these two interact during loading and unloading of ice. Then for the postdoc opportunity, this will be advertised in the spring, but you can already contact Aggie if you're interested. And then I just opened my email to, yes, this is a position that Sasha Bruna is advertising here at GFZ in Potsdam. And we're looking for a postdoc slash research software engineer, because we have a lot of different software packages at GeoZ, and we would like to couple them all. So if you're interested in such a multi-process modeling framework, then please reach out to Sasha Brunner or me, and I can lead your request on. And then what is this? Yes. Okay. And then we also have a 2-year postdoc, maybe, opening up. We are very hopeful that it will be funded, looking at cross-scale geodynamics in the Adriatic. So again, if you're interested in postdoc position with us, reach out to me or Sasha Pona. Thanks. Let's see, there's a lot more going on in the chat. I think those are links to, yes, to people, to advertisements. Great. Okay, Rene, you have your hand raised.
Yes, I don't have a position to advertise, but given the fact that we only organized this on literally the last minute, decided yesterday to add this to the program, and now we have so many jobs that were advertised, we should probably make this a regular thing every year to set aside 10-15 minutes to advertise positions with Aspect, or to let people ask for positions. Seems like a good thing to facilitate just connecting the people who are looking for jobs and the people who have positions to advertise. So I'm just saying this to hopefully remember myself to put this in the program next year. If I forget, then someone should remind me.
Yeah, great idea. All right. Do we have any other points we want to discuss? That looks like a no. We're also very close to the scheduled end time of this this block of talks. The plan is to have a half-hour break and then at the full hour reconvene and have another set of talks. So again, thank you for everybody for presenting, for participating, listening, and see you in half an hour.
And I will take over then from you. Thank you, Anne.